We're moving on to our next session, where we'll be zooming into the University of Malta, where the experts Tony Apolaroa and Karl Pelka from the Department of Physics will walk you through the wonderful world of quantum. Karl Pelka, who joined the QuantuMalta group as a PhD student in 2018, he currently works on cooperative effects of light and matter with photon radiation pressure.
Maybe a second introduction into what we now know as like the wave-particle duality. It puts us in some sort of identity crisis, right? Because we as people, we kind of think that you can be only one or the other. But Tony already introduced to you that we shouldn't be so distinctive about things. So first, I want to give you a short, like some pictures in your mind, what you should think about waves in addition to what Tony said. And maybe the most natural thing that we know about waves is, especially here in Malta, close to the sea, are those type of waves. So this is a very interesting object where we have like water waves. And what we think about water waves is how the surface of the water deviates from its mean position by means of something which happened beforehand. So if you follow the red dot, it goes up and down when the wave is propagating from left to right. And now, since Tony said already something about light, so how do we know that light is actually a wave? And so a short historical session on that is that this guy here, Heinrich Hertz, he was the guy, or he was able to produce electromagnetic waves. And what he did is basically, so he had balls on which he could switch, on which he could put a current, an exchanging current, and by that he could produce waves which looked like this. And here you see it's represented in a bit different manner, where you see something pointing up here and something pointing down here, which means a deviation from the mean value, just like with a water wave. And this is a 3D representation of what's happening when you have currents. And so the funny thing is that he found that these waves, they actually travel at the speed of light. And this was the first experimental evidence. This was the experimental evidence that light is actually an electromagnetic wave. So we saw that something will deviate. And here we have one-dimensional objects. And we see that something can deviate in two directions. So if we want to look at the light waves, we will go into what Tony showed you with the double slit. So this is our table here, because we couldn't give you like a show around. We go to this part where we have our laser pointer, something which I can, you can see me, something here, and we will impinge light on this double slit, as Tony said. And then we see what will happen afterwards, because we don't know so Tony showed us that there's different behavior. So okay, because Tony showed it already, I will just move on. So you should see me in the other camera. Mount the laser. And we remove the slits for now. So I think if you use all types of cameras, you should see the light that we actually have here. In the background of Tony's camera, you should see me working around, what I'm doing. And on the third, you see the slides, which are not interesting right now. So what we have right now is our laser, a red laser. And let's see what happens if I put in the double slit. Okay. Okay, I think we have it. So now what we see is this brightest spot here in the middle, and we see multiple fringes on the side, which are exactly what we saw with the wave behavior. So and this is indicative of wave behavior. So we showed here, or we proved to you, that light has this wave-like behavior. We can do another trick. We can turn off the light and use very different light instead. We can use, instead of the laser pointer, we can use an LED from my cell phone. And then we see what kind of behavior we will have there. Okay, I hold my cell phone. You see that it's on. I remove the laser, and let's see what happens now, Tony. Okay, it's not as impressive, but what we see is, let me put it here. What we see is that we don't see this behavior with the multiple fringes. We just see that we're casting a shadow, right? So in this case, a different type of light shows us that it actually behaves like the particles. We are basically shooting with a pump gun or with a shotgun at slits, and we don't see this magical wave-like behavior. This is very interesting. So light has different types of behaviors depending on which light source we use also.